Let's practice logarithms. Example 5b. Once again, we have a function. Our job is to find its inverse. And so again, finding an inverse of a function is old stuff. That was assignment 21. All right, flashback to that. And I have the link to those notes here again. And so finding the inverse of a function, we take it out of functional notation. You change the function into y. This is old concepts. It's just introducing a new idea within that old concept. And then, since inverse functions are supposed to do the reverse process of each other, you might recall that we switch the variables at this point, and therefore y becomes x, and x becomes y. And then we solve this new equation for y. A function has y by itself. After we switch them, y isn't by itself anymore. So again, we unravel this, we solve it for y, and I will point out to you on this one that since y is in only one term, we can use that, what's the furthest operation from y in the order of operations at each step in the process. So, I've had class after class tell me, I go, what do you think would be the furthest operation over here from y? And they go, add 12, that's way down the list. Yeah, you're right. So let's subtract the 12. Adding and subtracting are called inverse operations, all right? So x minus 12 would equal 8 times e, and so on. All right. Now what operation over here would be considered the furthest from y? Multiplying by 8. I agree. I'm just, year after year people yell these things out to me, so I would assume you'd be yelling the same thing if you're sitting there watching this and you're like, yeah, you should do that next. So we have x minus 12 all over 8 equals e to the 3y minus 5 power. All right, now this could be, so far those are our ideas we've seen many times before. What's new to you probably here, and I think I'm going to leave this slide and come back to the present day here. What you hopefully recognize at this point would be that we want to get rid of that e now, and that e is a base. Something that has a power attached to it. The point is, and look, they're switched around, but isn't this a base to a power equals something? A base to a power equals something. An exponential type of equation. And therefore its inverse would be to change it over from that exponential to the logarithmic, which was practiced multiple times on examples 1 and 2. So, I'm going to change this to a logarithmic. Log base e. Oh! Wait a minute, you bad hand. There's a special symbol for log base e. It's called natural log. All right? So, if you hear your brain, it's okay for your brain to think log base e, but your hand better write natural log. All right? Those are interchangeable. Remember, that's a special one where your base happens to be e. So let's not write log base e. That'll get you laughed at the math parties. It's called natural log. That takes care of that. And then following the pattern, that would then be applied to the x minus 12 over 8. And just remember that when you go from exponential to logarithmic, one thing to remember is that what used to be the power ends up being by itself. So again, what used to be the power ends up by itself. So just look at the pattern, follow it when you change from one to the other. I would think the remaining steps are easy. Let's add 5 to both sides. By the way, you'll notice I put that fraction in parentheses. That's the best mathematical way to show that logarithm applies to that entire fraction. And then we get rid of the 3 with division. And y is by itself, isn't it? So let's see, how can I pull this off? Going back to the inverse notes from a long time ago. Remember, after we got y by itself, then we expressed it as an inverse. And these were the notes again, I believe it would have been from assignment 21. So the idea would be that the appropriate math label would be that if this was g of x, this new expression would be the function called g inverse of x. And so we're going to write g inverse of x equals, and we just copy down that formula that we just built, the natural log of x minus 12 all over 8 plus 5 all over 3. I hope that fits in the screen here. I think it does. You notice my blue line here on the board that tells me where the edge of the camera is, hopefully. And there's our answer. Woo! All right. So again, we'll come back and we'll have one more of these to enjoy, and then that should wrap things up for logarithms. So one more function inverse. All right. Hang in there, everybody. Y'all doing okay? Y'all take care of yourselves, all right? You take care of yourselves and your family. I miss having you here, but we're doing the best we can. So we can do this, right? We can do it. Scrawny arm. All right.